In the 18th century, European economy started a drastic transformation. And it literally changed all areas of production, of society, economy and business models. We call it, and you know it, the Industrial Revolution. And the question is, what was so special about it? Human beings have always used tools and technology in some form, but this one was the most crucial tipping point until today. And the answer is, I think, it's because it was an energy revolution. Until then, human beings have used muscle energy from humans or from animals, and then suddenly they started using combustion energy from burning coal, wood, oil and natural gas. So energy revolutions have always played a vital role. And now, again, 2021, again we live in an era of an energy revolution. And this change is inevitable, it's necessary. All over the globe, consciousness grows that we cannot use fossil fuels any longer. It's an old technology, it's a technology of the past which will not bring us successfully through the 21st century. But how will the new energy paradigm look like? One thing is for sure, it's going to be a mixture of different technologies. And today we will focus on one very promising candidate, on green hydrogen as an energy storage, as a possibility of storing green energy. And we will discuss it with a very special guest, with Professor Michael Sterner. He's a professor for energy storage at the OTH Regensburg and author of numerous publications in this field. He is one of the inventors of the power-to-gas technologies, a member of the prestigious IPCC, and last but not least, he is, like so many great scientists, like for example Albert Einstein, who was a passionate violinist, a musician who started composing as a child. So I think it's a very interesting guest we have here today. I'm really excited about this talk. My name is Christian Uhle, I'm a philosopher, and I'm the host of this series of dialogues financed by the Export Initiative of the Federal Ministry for Environment. And I'm quite curious about what's going to come. So let's have a look. Yeah, thank you so much for joining us, and thank you so much for being here for this dialogue. And as far as I understand it, the basic principle of hydrogen energy is basically quite simple. So if I understand it correctly, you have water, which we all know is H2O, and then you need a lot of energy to basically separate the H2 from the O, and this can be any form of energy, and this can be fossil energy, but it also can be green energy, like solar energy, for example. So we separate it with electrolysis, and then we have them separate, and then we can store them somewhere, and when we put them together, like for example in a fuel cell, then this energy is being set free. This is how I understood it. I don't know, did I explain that correctly? And if it's really so simple, why do we not already live in an era of green hydrogen?
You're absolutely right. It's that simple. We need, first of all, green electricity to do this. Because as you said, we can do it from fossil energy. These are hydrocarbons. So maybe you take your O, your oxygen, and draw a C and O2. What nature does is putting hydrogen and CO2 together in photosynthesis. So by the help of solar light, water is split into hydrogen and oxygen, but nature doesn't stop at hydrogen, so it combines hydrogen and CO2. It takes CO2 from the air, that's what the plants and the trees does, and then you have hydrocarbons. And this you can use and combust. And then you have biomass, this is CO2 neutral, but if you leave it in the ground for many, many years, then this is fossil energy, and the CO2 which is released when you burn hydrocarbons is getting back into the atmosphere, and that's causing the climate change. So in order to really come away from this fossil hydrocarbons, we need to get green hydrocarbons. And if we can do this with hydrogen alone, that's fine. But so far we didn't have the technology to use this because fuel cells weren't developed that much and very expensive. So kind of my invention was to copy the idea of nature to do photosynthesis and combine hydrogen with CO2 to create green hydrocarbons. Then you have green fuels, then you have green methane, which you can store, green gas. So everything can then run with renewable energy. But the first step to do this, you need water, air, and electricity. And the electricity should be then wind and solar or hydropower, because these are the cheapest energy sources we have on the planet.
But if I have like what you call green methane, like I mean, if I burn methane, or if methane gets into the atmosphere, it's still like a climate gas, isn't it?
That's why these caverns and storage issues have to be very tight and proof. But this is kind of natural gas which we use. Methane is natural gas, basically. And well, it comes from nature, but it causes climate change. So we need to replace this natural gas by renewable gas. And the idea is really to, like in music. In music you have chords, you mix chords with lyrics, with melodies. And I did this in the energy system. So I'm an electrical engineer with a chemical background, and I also studied physics. So the combination of the electricity system and the gas system brought me to power to gas. So then we can transfer cheap wind, solar energy via electrolysis and hydrogen to gas, and then store this in the existing infrastructure and really have it for the times when there is no wind and solar. So we can really have a stable power supply without blackouts, with a total 100% renewable system. And so this was the intermediate step in order to bridge the time until we have hydrogen economy. And so the hydrogen itself, we can do this as well, but it's technically not that easy, because hydrogen is quite light and it goes into different metals, and it's explosive. So we have to handle this, and we can tame it by combining it with CO2. And then you can create green fuels for aviation, for shipping, for whatever, you name it. So really by doing this like nature does, because nature also doesn't stop at hydrogen, it goes on to hydrocarbons. But if we end up in a world in the hydrogen economy where we have technologies which are reliable, safe, and affordable, we do not need this intermediate step by combining hydrogen and CO2 again.
Ah, okay, so that's like kind of for this transition period.
That's for the transition period, because you have really thousands of kilometers of natural gas pipelines, you have thousands of cubic meters of natural gas storage. You can reach, for example, in Germany, 50% of the households, of the houses with natural gas. So many systems depend on natural gas, also in the industry, also in transportation, and you can replace this one-to-one by this power to gas, this synthetic natural gas or real natural gas.
But this is actually an interesting point. So we can use the existing infrastructure for natural gas for hydrogen gas. Is that correct? Or like we don't have to change anything? Like, I mean, sounds a little bit too good to be true.
Right. You can, if you combine hydrogen with CO2, yes, because then you have this real natural gas, and then you can use the pipelines, you can use the storage, you can use the applications. So you have everything from your energy storage system. The only thing you need is the plug. So to plug in from electricity to gas, you need this electrolysis and methanation unit. And you can leave away the methanation unit once you are in a 100% hydrogen system. But then you really need to dismantle the storage infrastructure, the transport infrastructure, change all gas turbines and change all boilers which are in our houses. So the first step would be really to blend hydrogen into natural gas and then use it in existing applications.
Okay, but then I have to get a better understanding, but now you're not talking about fuel cells, no? You're just talking about like having this gas and kind of burning it without using fuel cells. And fuel cells would be the next step in this transition, so you're thinking in different steps towards a hydrogen economy. And now you described kind of the first step in this process. That like, okay, so I have a lot of questions now, but like basically maybe you can say a little bit about this vision of the hydrogen economy after this first step. And I'm also wondering like if we actually do invest into this creating like this kind of green methane or something like green fuels, like if we invest into this technology, doesn't this kind of prevent investments into the next step? Like, is it really a transition, or maybe we're going to get stuck there? Because I mean, we do already need to use a lot of resources to do the first steps, and this leads us into a little bit of a different direction, doesn't it?
Well, let's put this question into a broader context. From the beginning of mankind or civilization 10,000 years ago, we always used biomass, we used solar energy for drying purposes, biomass for heating and cooking. We used wind energy to sail and also to for the windmills. So we had a 100% renewable energy system, basically, and we had the horses to do transportation. And one horse, one day, you could make maybe 100 kilometers. So now from the first industrial revolution with coal and then later oil and gas came in, we really changed our complete way of living. So most of us are no longer on the field in agriculture, because we have tractors and we have lorries and we have all the machines that do this job for us by using fossil energy. And we have also created fertilizers with the help of fossil energy, and we doubled by this the number of people living on this planet. So now we know that because of man-made climate change, because of burning fossil fuels, we need to change the system completely and go back to where we were before, 100% renewable energy system. And then you have different options. Biomass is limited in potential and sustainability because we need also some areas for food and fodder. Then we have hydropower, which is also limited in its potential, geothermal energy, and then solar and wind energy. And most of these forms we can harvest most economically by using electricity. So wind and solar energy are really the energy forms that have the largest potential worldwide, the lowest costs. They're only half of the electricity price of new coal, wind and nuclear power plants. And they use little land area compared to other sources. So their environmental impact is also quite okay and acceptable. So, but then you have electricity. And what to do with electricity in the winter where there's no wind and no solar energy? So then you need some energy carrier that is to be able to be stored. And I wrote a handbook on energy storage where I really, these are like 900 pages, really 2 kilograms of knowledge, where I showed that batteries and pumped hydro power systems, storage system, are not the solution for this problem, how to store wind and solar energy for a long time. Batteries work for one day, but not for a month. So then so that's why we need something that is to be stored. And the question, yeah.
Tell us, like in 2 sentences, why this is not a solution without going into the 900 pages. Because I mean, like, there's like a lot of hopes, like when we think about the mobility sector, you know, it's like e-mobility, it's the big thing. So like, but now you're saying like this is basically not really the route to go, or are we talking about different areas?
So we have basically 4 sectors. We have the power electricity sector, we have residential building sector, we have transport, mobility, and we have industry from the emissions here. Then we have also agriculture, but I leave this aside. So in all sectors you need energy to run the system. And electricity, I just talked about, it's wind and solar plus hydrogen or renewable gas to be able to store it. By combining existing electricity and gas infrastructure, you can solve this problem. Second, we have the residential and building sector. There we depend largely on gas and oil. We need to replace this by biomass, but then also wind and solar. So how can we bring wind and solar energy into the buildings? First of all, of course, via heat pumps, because they're very efficient. But you have sometimes many old buildings where you cannot build in heat pumps. So there, renewable gas and hydrogen will be interesting, and then fuel cell comes into play. Third, we have the transportation. And transportation you have to distinguish. The best mobility would be the mobility you do not need. So to live in cities where you can live in the upper floors and down you can buy your daily needs. And you do not need to drive anywhere or to work via online tools or whatever.
But that would also, like, from a philosophical perspective, that's like not really a utopia, no? I mean, that would mean that we don't meet so many people in the streets. I mean, like, sometimes, like, moving somewhere is also...
Yeah, I know. But then you can go buy food, you can take a bike, you can take a train, whatever, a bus. But then the car comes in. And of course, the car is kind of a cultural thing for especially in Germany. And as we invented the car, we also love the car. But the car will be, in my point of view, 100% electric. Because the car, as I said before, formerly we had horses that went 100 kilometers a day. Now we have cars that go 1,000 kilometers. And that's because of the energy density of these hydrocarbons. And if you go to hydrogen, you have a range of 600, 700 kilometers. If you go to hydrocarbons, so kind of green diesel, we can produce also via hydrogen, then you can go your 1,000 kilometers. But basically, the most efficient way is to use electricity directly via heat pumps, via electric vehicles. But we do not only have the cars, we also have the lorries, we have the ships and the planes. And they go long distances where there are not yet batteries available. And there comes the fuel cell in.
So you already talk about like different applications, and now you, for example, mentioned that when we talk about cars, then hydrogen doesn't play such a big topic, or that we actually, this trend of e-mobility does have like some form of like correctness in its own right. It could also be interesting for the AHKs around the world to know a little bit like, okay, we have different applications, but like what kind of role will like hydrogen, green hydrogen play in different countries? Because like, I mean, like apparently like the whole topic is like super complex, you know, like we have like these different technologies, we have different applications, you know, but I mean, the situation is a little bit different in every country, and maybe it's not the same role that it will play in Germany as it will play in Kenya or Chile.
Maybe I take the example for Germany. We have a very densely populated country, so we will extend our wind and solar turbines and capacities, but to some degree we are limited. So, and we are really an importer of fossil energy, and we want to become then an importer of green electricity and hydrogen. And this is very interesting, especially for partnerships with GIZ and other players. And then we look, of course, towards Chile and Argentina or United Arab Emirates or South Africa, because there you have vast resources of wind and solar in no man's land. So really where there's no population, there we can really harvest double energy compared to Germany. And then if you convert this energy into a transportable good, it doesn't matter if you lose efficiencies like in Germany, because you have so much electricity that this is not a matter of price. Yep.
So one potential is maybe to for some countries to export energy who could not export energy so far, because they can use like actually green energy and then like export it and gain revenues for their country.
Like you explained, formerly, I mean, the oil countries have been oil countries by accident, because formerly when this hydrogen and CO2 was combined and stored in the ground, this is not distributed evenly around the globe. So we have some rich oil countries and gas countries, and others do not have anything. But we all have wind and solar energy and hydropower. So every country with good wind and solar and hydropower resources could become an exporter of hydrogen or hydrogen derivatives like power to X. That's a term I created, which means electricity to something you can use. And it can be hydrogen, but it can be also ammonia for fertilizers in the industry. It can be, or you can use also ammonia for shipping, or it can be methanol, which can be transformed to gasoline. That's what Porsche and Siemens do in Chile. and then they export the gasoline to Germany to fuel the existing combustion engine cars, because we will still have many combustion engine cars around the globe. So this is a solution for them. And then we have also countries like Brazil or Norway that think, okay, I have the natural resources and I have electricity, I can create hydrogen, I can create also green steel. And formerly, steel was manufactured where there was cheap energy in form of coal. We have this in the Ruhr area, in other places in Germany. But now steel manufacturing, especially if it needs to be green steel, will go to the places where there's cheap electricity. For example, I invested a project in Congo where they have a large river, the Congo River, which could power 13,000 megawatts of electricity, and they do not have a place where to put it. And the transmission line towards Egypt or South Africa didn't work due to political restrictions. So they could create hydrogen and hydrogen derivatives to become a major exporter of this. But then, of course, you need stability. And for example, one of the countries with the highest potential is Somalia. They have good winds and good solar energy, but it's a failed state. So you need also some stable political surroundings and settings to be able to export it. And that's why this project of Siemens focused to Chile, where I also studied and worked for the HK and for the Embassy of Germany for some time in 2004 to really harvest the vast wind potential in the south and the vast solar potential in the north of Chile.
That would like change global power structures, what you're describing, no? I mean, like power is power. And as we have like a very nice example with the Emirates, for example, their whole role in the world basically rests on that they have the oil, and now basically this could change. But whenever power structures change, there's also big resistance, no? I mean, because when there are people who can win something, there are also people who can lose something, no? I mean, like, is this really feasible, or?
That is the reason why the fossil industry really paid a lot of public relation work to tell people that climate crisis doesn't exist. And now we see that it's real and that our warnings of us scientists have been correct. And for me as a scientist who is working for the government and working with many, many colleagues, for us it would be very, very kind to see the same appreciation for climate science that we see for COVID science. And COVID showed us that if we really realize that this is a crisis, then we can really act fast and vast. And I hope that we now see, okay, it's basically the same with COVID and with climate, because we are all interconnected via the air, every human with each other, via the breath and breathing. So there's CO2 in, and there's also the virus in, and the virus is quite fast and having a personal impact. That's why we acted so fast. With the CO2, it's on a longer decades that changes come, but basically also everyone is affected. And that's why it's so important to have such projects with hydrogen, or to empower people to really create their own business based on electricity or hydrogen. We see this in Africa. I lived in Kenya 2 years. That if there's electricity, bam, the industry grows. And we really need to step into wind and solar and leave away the intermediate step of fossil or nuclear energy, because this is much more safer to handle. And then this can create jobs, and then people do not need to leave their homes. As we push them to leave their homes and to come to Europe or other places because of this bad situations which they have economically, but also due to the climate change, because climate change is affecting the equator countries much more than the northern countries or southern countries. So they really have the pressure put from us Western nations by our emissions, and that's why it's our responsibility to really help them to overcome climate and energy crisis, and to empower them to create their own fuels and electricity, and they have the resources.
But like, I mean, like as a philosopher, I'm like, so I'm not against technology. I mean, like, of course, technology plays like a crucial role in like solving a lot of complex problems. But at the same time, as we know from the past, technology also creates a lot of problems. And I mean, the basic problem of climate change is because we use so much technology, like to put it very simply, you know. And so sometimes it's I mean, Albert Einstein, you know, like who was also a musician like you, he said like we cannot solve problems with the same way of thinking that created these problems, you know. And I think there's a lot of truth to it. And just like sometimes I'm just wondering, like, is it really so simple? Can we solve these complex problems with a nice technology? We just like need like this new fancy technology, and then we can just like continue with our business as usual and like produce the way we produce and stuff like that. Isn't that a little bit too good to be true?
Well, 3 points. First, technology is neutral, like money. It's the intention behind that makes it good or bad. You can use nuclear power safely to some extent, or you can create nuclear bombs. And the same you can do with hydrogen and whatever. So it's the intention behind our decisions to do things. The same with money. So second, we need a multidisciplinary approach. So it's okay to go in one discipline very down, but then as you said, you do not find any more solutions. So for me, I love psychology. I study music. I'm an engineer and a physicist and so on. But overall, it's really there the solutions come, and then you just have to take them and use them. And of course, then it's technology which can be the solutions, but you need a society that really wants to apply this. And our society basically is now an economic religion society, because we believe in growth, but growth is limited, and growth has been created because of the use of fossil fuels. So if we have to get rid of these fossil fuels, then we have to rethink our economic cycles, which are basically you take some resources, then you have an industry that produces goods, then you sell them in the shops, then you consume them at home, and then you throw them away. And this one-way direction does not work anymore, because we are overusing the planet, we are bombing the natural limits of the planet, and so the planet is quite tolerant, but this can come to a bad end. That means the extinction of humanity, and especially in Germany or other places which won't not be livable and available in 10-20 years if we do not change. So we really need to rethink and redesign also the economic system to come more to our circular economy, to repair, reuse, and so on, and not do what we've done the last 100 years. We had formerly the complete cycle at one place. And now on the global economy, you take the resources from the Congo, you produce your battery in Chile, and then you sell it in Europe, and then it ends up again in Namibia, where children deplug the old batteries. So that's not the solution. No, we should use globalization to create and solve our common problems, but not to create more. And the drive behind this is economic growth, and economic growth will be our death if we do not combine economic growth with CO2 emission reduction and decouple economic growth from CO2 emissions.
I'm also like quite skeptical about the paradigm of like eternal economic growth, you know, because like sometimes it's lost its purpose, you know, because like implicitly we think that economic growth is something positive, but like when we think why is it something positive, then we start actually thinking about like about the purpose of the whole thing. But like when you think about the promises of economic growth, then often these promises are not really kept, you know. I mean, like disparities grow, like the difference between rich people and poor people, for example, and like our planet like more and more comes to its limits. But isn't that also like a little bit of a privileged situation? Because I mean, in a country like Germany, we can like criticize the growth paradigm, but I mean, like in poorer countries, you know, it looks a little bit different.
Of course, you're right. We cannot compare the situation in Germany with all other countries around the globe, but we have to admit that unlimited growth on a limited planet is not possible. This is a paradox. And we have to admit this and then change our acting on this planet, because otherwise as I said, we will run into death. And nature gives us the feedback already very, very harshly. It's not little. I mean, if you see the floods and the heat waves around the planet, this is man-made climate change. And so we need to act really fast. And we talk about this since 20, 30 years, and the fossil industries always diminish that and block that. But basically, it's like a sprinter who is running his 100 meters and he does not stop. And you, 1 meter before the goal, and there's a wall, you shout, stop. And it's kind of really, really hard to stop and avoid damages. So we have already the damage at 1.1 degree global warming, and we would have much, much more if we do not really fastly decarbonize, and there hydrogen plays a key.
To see the full picture, I mean, like, there are also opportunities, no? I mean, there are opportunities, there are ways like where you can combine like an ecological transformation with like economic opportunities. Like sometimes they contradict, like if we design the system in a way like now, it can contradict, you know, but like there are opportunities. And like also, since like our dialogue takes place as part of a program financed by the Export Initiative of the Federal Ministry for Environment, I think it's also interesting to talk a little bit about these opportunities. Like, do you see some?
I see COVID as a big, big chance to really change things. Now we have the Fit for 55% emission reduction at the EU level. That brought China to commit. We get carbon neutrality by 2060. Also the United States, carbon neutrality by 2050. So we have the big players now on one track. And we really have the opportunity to make it, to really stabilize our world at a 2 or 1.5 degrees Celsius warming, which is quite challenging, but it's still possible. And the good thing is we have all technology. We have developed many technology, especially renewable energy and also hydrogen for decades now in Europe and around the globe. And we have a pole position in Germany because, as I said, after my invention of power to gas and before we had many hydrogen works, this really exploded, and we have a global map where we see that Germany is kind of the key country besides Japan for hydrogen technologies. And this can be a pole position, like we did it in battery and solar energy, that we are not only inventing and doing research projects, but also to bring people to work and to export our technology, because we are second champion in exports after China. So it really matters what technology we export. If we export technologies that use fossil fuels like combustion engine, or if we export green tech. And this can really create many jobs. And the strongest industries in Germany are the mechanical engineering part and chemical engineering. And both combined leads to hydrogen and power to gas and electrolysis units. And to create really green hydrogen, you need a lot of electrolysis units, you need fuel cells, and this can really create jobs. And by exporting the technology, you give these countries that haven't been energy exporters yet really the chance to empower themselves to really get independent in energy supply, to use renewable energy, also wind and solar, where we have large manufacturings also in Germany and large companies who do exports. So that's really a big change and a chance to, and a win-win for both our partner countries and Germany, because we transfer our know-how and technology and empower by doing this other nations to become more independent, energy reliable and safe, and to create wealth in their countries by using resources which they didn't use yet. So it's kind of these wind and solar and hydropower rich countries become the new oil nations. And as it's more distributed around the globe, it's much more democratic than just have some few oil countries which dictate the world.
It's a very simple thought actually, but it just means to just like in this phrasing, it just comes to me now for the first time that I have it so clear, you know, even though I was thinking about it before, but like it's just understanding that sun is also a resource, is a natural resource for energy, and wind is a resource, because like when we say resources, we have resource rich countries, we have resource resource poor countries and stuff like that. But we never think about sun and wind as resources usually, you know? And that is just like a complete shift in like how we see like countries' positions also in the world.
Right, and as I said, we used it since the beginning of civilizations for thousands of years, these resources, and now they have been shifted towards fossil energy, but we need to get rid of the fossil energies because of climate change. And then, of course, the future lies in wind and solar resources. And there, of course, you need steel, which you can manufacture via hydrogen in a green way. And of course, you need lithium and so on. And these resources are not that limited. We have recycling technologies that are able to cope with these issues. And our Federal Ministry of Environment also calculated that we have enough resources, also rare materials and elements, to do this energy transition, also in Germany, also around the globe. And of course, we will change our habits as well, but it's a combination of changing the way we use technology, what technology we use, and also how we behave and eat and use energy. And one big opportunity I'd like to add is, of course, also, like I said, in Chile or other places, to create liquid fuels out of hydrogen, because these are then CO2 neutral, kerosene and diesel for shipping on long distances around the globe or for flying, because although flying is very climate dangerous and harming, we will still need to have an international exchange.
But let's not confuse things. Just like to make it clear. But this is not completely climate neutral. What you talk about, no? These fuels, these are like we're talking about this first step. Yeah. Like climate neutral or close to climate neutral is only like actually using green hydrogen directly to burn it or to put it into a fuel cell and then transform it into warmth or electricity, right?
Yes, you would have the same by using electric kerosene, so a derivate of hydrogen. But then still, no matter if you fly with fuel cells or whatever, you have in high levels of the atmosphere vapor, water vapor, that also causes climate change. So no matter what fuel you use, you still have some climate effect. But it's lower than using fossil kerosene. And so for the long distances and, for example, for manufacturing steel and chemicals, we use a lot of plastics. These are all made from fossil energy, oil and gas. And we need to replace this totally by hydrogen and hydrocarbons that come out of hydrogen and CO2. And the good news is that we can do this, that it's possible. Still, of course, after 2050, we need still some technologies to remove the CO2 from the atmosphere. But just to rely on this is very dangerous because it's not yet a safe technology. So it will be wind and solar plus hydrogen plus batteries and so on, together with some combination of changing in behavior. But then the chances are much more better than the risks. And especially if we do not do this. Alone in Germany, I think we had billions of euros alone in June on damage out of climate change, of flooded houses and all the lost agriculture yields. So if to do nothing and to not invest into hydrogen and wind and solar is much more expensive because you do not stop climate change. And it will cause much more death people than any COVID crisis. So we really need to act fast and strong around the globe to really solve this climate issue. And the good thing is that the technologies are there.
You said the technologies are there, and you also said that Germany does have a very good, like German companies do have a very good position, like when it comes to hydrogen. Just like a tiny question, but is this rather like a handful of like big companies we're talking about, or is the so-called Mittelstand, KMU, kleine und mittelständische Unternehmen, especially Mittelstand, are they also playing a role? Is it like a diverse field or very monopolized, centralized?
It's like in the wind industry, you have the big players like Siemens, but you have also very, very many small players. For example, in Bavaria, where I live, more jobs are related to wind energy than to solar energy because of our electrical and mechanical industries. So, but in future, I mean, we have many jobs in the automotive industry, in the chemical industry, and they all will have a shift in paradigm to come away from fossil technologies into renewable technologies.
Is there some form of like platform where all these companies are kind of listed or something? I imagine that it could also be interesting for the AHKs to like get a little bit of an overview like what we're talking about.
Well, the Federal Ministry of Environment did develop with my old group at Fraunhofer a Power to X Atlas, where you can really check where are the sweetest spots for hydrogen and Power to X on the world. That's a very good tool. Then I developed with colleagues from GIZ and the Federal Ministry for Economic Cooperation the system H2 Global, which is a double auctioning system. So Germany buys hydrogen and hydrogen derivatives for 10 years. It's guaranteed that it's paid, and then it's auctioning this year by year in Germany, and the gap is financed by the government basically and a foundation. So this is a very interesting project, H2 Global, where I also did the modeling behind that. And it's interesting. We will start with not with pure hydrogen and fuel cells as you started this conversation, but with ammonia, because ammonia can be used as green fertilizer. And imagine yourself, for example, in Zimbabwe or in Gambia or in Brazil, you take wind, solar, water and air, and you create your own fertilizer. You no longer depend on fossil resources. So ammonia can be really transported around the globe. It can be used as chemical feedstock, but it can also be used for maritime shipping. And the second one will be methanol, because methanol is both as well. It's toxic, okay, but it can be blended into gasoline to use existing combustion engine in transportation, but it can also be used as a feedstock for the chemical industry. So ammonia and methanol will be kind of the first hydrogen players, and then as fuel cells get ready in the long vision, we will leave out the CO2 completely from these processes as far as we can do this, and then be in a hydrogen economic world.
You mentioned like several times that like the technology is there, like it's all possible, you know, like I mean like, but still I mean like it's not really there, it's not really implemented on a very large scale like green hydrogen technology. So I mean like what are the obstacles? And I know that one obstacle is the price. It's still like just like more expensive than alternatives. So what are the obstacles? How can we lower the price so it becomes more competitive? And basically, yeah, what has to be done?
First, communication, what we do actually, to really tell people and to bring the knowledge to the people that the knowledge can unfold. Second, we are good, as I said, in inventing things, in researching things, but we need to bring it to the market. And one obstacle in market introduction is, of course, the price. If you create green gas, it's kind of 5 times the price of fossil gas. So what to do? The most important instrument is the CO2 pricing, because CO2 is causing global harm and damage. And this global harm and damage, which is external, needs to be internalized into the calculations of the CEOs of this world. Because so far you're optimizing your own business, and if you do not have a CO2 tax or CO2 price, then it's not in your scope. So their policy making comes in. We need to have tough policy regulations on CO2 pricing, that the controller and the CEO of a company sees, okay, if I take this decision, it's not economically feasible. So we change to green technology. And then third, we need long-term thinking. Not only in 4 years for my period where I'm elected as politician, or for the next business report as CEO for the shareholders to be satisfied. We need to think in decades. And of course, we have a lot of investments to take now, but the revenue is positive as we avoid fossil energy imports, as we avoid climate change damage. And then overall on the globe, then it makes also not only ecologically, but economically sense. So technically, it's doable, it's feasible. economically it makes sense on the long run. We need to push it over a regulatory framework. And ecologically, it's a must to save our life on this planet. So everyone can do something in his place, and that's what I always tell people. You cannot save the world as a whole, but you can save your world and do what's in your action. And if I'm a politician, I can do something. If I'm at AHK, I can also bring the ideas to the local industry and people and policymakers to inspire them to move into this vision of a green, safe future with green tech.
Thank you so much, Michael. Thank you very much for taking the time. It was amazing. I learned a lot, and it was really inspiring too. And it could really sense your personal passion behind it and how you combine it with all your scientific knowledge, and great. So hope to stay in touch, and
the symphony of life can continue with us.
Yeah. Perfect. Okay. Bye bye. Hi. That was a very inspiring conversation to me. And I think we actually captured a lot of different perspectives. I realized once again that of course technologies alone cannot solve all our problems, like the problem of climate change and the energy problems we're getting ourselves into. I mean, we also do have to change in part how economy works, how society works. We do have to change our consumption patterns also. But of course technologies play a vital role in this, and we will need energy in the future. And here, green energy is the key, and we need ways to store it, to transport it, and to make it useful. And green hydrogen can actually play a very important, or can be a very important element in this transition. Sometimes there are these little moments where something clicks in your head. And for me, it's this super simple thought of understanding that sun or wind is a resource, like oil and gas was a resource in the past. And this is something that I will really take away from me, this very simple, but I think also very important thought. And I mean, there's a lot of work for all of us to do, and I hope that also if you're a member of the AHK or you work in a different field that's closely related to business, to further spread these ideas, because there are certain areas, and this may be one of the areas, where also ecological transformation can go along with certain economic and business opportunities. So I think there are still a lot of open questions, and this was certainly not the last conversation. There's also a lot to learn in the online course provided for the AHKs, but I think I'll just let it sink in for the moment, and see you in the next time. Bye.